how by buying or selling, by buying calls or puts, it was possible to have a significant gearing on our investment. So in other words, get a significant additional return that you could have percentage return that you could otherwise have got by just buying the shares, but also it can give you a significant 100% loss if you make the wrong bet effectively. So why would you go about buying options then if you've got that risk? Well, you actually, for example, might have your own research might show that you've taken a view on a particular market or a particular share, and you think that the thing is going up. You've got confidence that you do think it's going up. You might also just be a bit mad and taking a bet. You know, it might be like betting on horses or something like that. You might be wanting to bet in that way. Another reason you might do it is that you might be worried that if you're holding the actual shares, you want to insure yourself against if the share price goes down. So you might be buying put options there for a fraction of your total wealth, which is a way of making sure that you protect your money, your investment in your shares. So it could actually be both a purely immoral speculative operation, or it could actually be a very strategic hedging operation to minimize your risks. The writer, why would any writer want to issue this? Because clearly there's a one-sided contract. Well, the writer actually should be paid a premium, or we'll work out what the premium should be in order to make that, to write that option. And the trick is that there's a fair value that the writer should charge you, and then there's the actual value that the writer should charge you. And the fair value, if the writer carries out a hedging strategy appropriately, is the value at which he's going to, or he or she will break even. So he expects to make a profit by charging slightly more than the fair value. So he takes the fair value and then invests it appropriately, and then anything on top of that is just his profit. Okay? So that's essentially why a writer would do it. But of course, a writer has to be very careful and to carry out a proper hedging strategy. Otherwise, they're in trouble. They could make serious losses. Okay, so to show why that, to build up to that, let's now start looking at payoffs for vanilla European options. And so the payoff that is, sorry, there should be K's, not E's. So if I have a European vanilla call option, okay, European vanilla call option with strike K and expiry T, then the payoff as a function of the time, the underlying asset price at expiry, call it the value of the option, CT. This basically is 0 for ST up until K, the strike price, and then it rises linearly like ST minus K for ST greater than K. So the actual payoff at expiry is the maximum value of ST minus K and 0. So if ST is greater than K, then this number is positive. It's bigger than 0, so the payoff is ST minus K. If it's less than 0, so ST is less than K, then 0 is the biggest number, so the payoff is 0. You'll also see this sometimes written as that, okay, with a plus sign in the literature. Just means the positive up sign. So the idea is that you make this the call option expires worthless if ST is less than K, but you start making money as ST goes up to K, from K. The put option, so the Euro vanilla put option, okay, with strike K and expiry T, that has the following payoff. So you remember you sell a put option if you believe the share price is going down. So it expires worthless if ST is greater than K, but clearly if the share price goes below your strike price, you start making money, which is why you have a put option. So it goes up to the maximum payoff of a put option is K, okay, whereas the maximum payoff of a call option technically could be infinite. If your share price went up to infinity, then you could have an infinite payoff. So the payoff here is given by the maximum value of K minus ST and 0. So when K is greater than ST, you get, this goes like K minus ST, because that's positive. When K minus ST is negative, up here, then the maximum value is 0, so the payoff is 0. And you often again see this written as K minus S with a plus sign to show that it's the positive sign that you get. Okay. So, if we now draw the same diagrams from the writer's point of view, so this is for the payoff for the holder. The holder makes a profit if the share goes up. If you are the writer, what is the payoff? Well, the payoff is the opposite. Okay? So that goes down like minus ST minus K. So this is the payoff for the writer, because this is the amount of money that the writer has to give to the holder, so that's the amount of money they're going to lose. So potentially, there's potentially an infinite loss if the thing keeps on going down. If the share price went to infinity, the writer would have an infinite loss. Likewise here, the payoff here, as a function of ST, does that. So they get break even for ST greater than K, but they lose a maximum value of K. Which is less than infinity, okay, in general. So, the writer stands to really expose themselves, right, if they don't do a hedging strategy. And the unfortunate adjective is taken is naked. If you are naked, in other words, you have not hedged your bets, then you stand to lose an infinite amount of money, okay? So, you will be absolutely stark raving mad to end up in a naked position here if you're writing calls, because you have potentially an infinite loss or an infinite liability. Okay? Here you have a bounded loss of minus K, alright? And the key thing is, in order to compensate the writer for that potential loss, the holder has to pay the writer something up front. Okay? That's like an insurance. So it's basically saying, I'm going to pay you something up front that will give you the ability to invest appropriately in order so, you know, if it's a fair payment, you're going to break even, whatever happens, you're not going to suffer an infinite loss. But for that, I want the right to get that payoff. And in the same way here, there'll be a premium paid from the holder to the writer, in order to compensate the writer for the potential of that loss down there. So, a writer would be mad to end up in a naked position. If they take that money and just leave it in the bank and do nothing with it, they'd be absolutely stupid. What they have to do is they have to take that money, invest it appropriately in a way that we'll discuss later on, and if they do that in the correct way, then they will end up with enough assets so that they don't lose, they're not exposed to that particular loss, but magically they can still produce the assets that are needed in order to satisfy the contract if necessary. Okay, the other thing that you can do is, although these are two separate contracts, you can put them together to make what's called a synthetic option. We'll see later on that the mathematics governing the addition of options is linear, so you can have linear combinations of these options to get different types of payoffs. Okay, so you can have payoffs, for example, which have got, say, a payoff like that as a function of time. Okay? And this you can form from a combination of call options, put options, and other options if necessary. Right, so having established that in order to compensate the writer for the potential of this loss, we now have to start thinking about what that compensation should be. So one of the possibilities that you can have is, let's say that you have a particular asset. Let's say it starts at 100 pence. And let's suppose, through crystal ball gazing, you know that there's a probability of a half that the asset is going to rise to 120 pence in a certain time period, or by the end of the period. So this is at t equals 0, this is at t equals t, the expiry time, or it's going to drop to 80 pence. Okay? So, how much, if you're going to say you want to set up an option for that, a call option, how much should you compensate? Well, let's have a look at the expected value of the payoff. Okay, what's the expected value of the payoff of the call option? Well, if you end up in this region here, let me just draw so that's C0. The payoff is either going to be, well, it's the max of, sorry, wait a minute, blah, blah. So I'm going to have a strike of 100 pence. Okay? So let's say I'm going to put my strike level in at the same level as the share price starts at. It doesn't have to be, but I'm just doing it like that. Then the payoff is going to be the max of ST, 120 minus 100 and 0. And down here the max of 80 minus 100 and 0, with a probability of a half and a probability of a half there. So if I look at what this is 20, max of 20 and 0. So the call option has a value of 20 pence at expiry, and down here it's got a value of 80 minus 100, which is negative. Max of that negative and 0 gives me 0 pence. Okay? So if you are in the scenario, so this was k equals 100, say, then if it goes up to 120 pence, then you're in that scenario, and if you're at 80 pence, you're in that scenario. Okay? So transferring that down to here, you can see that there's a potential for the writer to lose 20 pence. Okay? So the expected value of the payoff, okay, what is it going to be? Well, it's a half times 20 plus a half times 0. So the expected payoff that the writer is expected to have to pay out is 10 pence. Of course, they either pay out 0 pence or 20 pence, but the expected value, if you could run that experiment over and over and over again an infinite amount of times, the average payout that the writer would have to do would be 10 pence. Okay? So you run this an infinite number of times. Sometimes it paid 20 pence out, sometimes they paid 0 out, but on average it would tend towards 10 pence. Okay? So, other things here about interest rates and what have you, but it would seem that a fair value of that option at the origin, t equals 0, would be 10p. Okay? So I haven't worried about hedging strategies yet at the moment, but purely on a pure average basis, a fair value of that option might be 10 pence at the initial value. So the idea would be that the writer would pay the holder would pay the writer 10 pence for the privilege of holding that option, and sometimes they'd make money, sometimes they wouldn't make money. Okay, the holder. Okay, on average, the holder with 10 pence, if they were paid 10 pence at the beginning, on average the holder would break even. Okay, because the average payout will be 10 pence. So this seems like a relatively naive approach, but it's not too far from how you go about valuing the thing at the end of the day. There are complicating factors, but we'll worry about those later on. So what would that particular writer do with that 10 pence? Well, they would have to take that 10 pence, invest it appropriately in the stock market or in other ways, in order so that they hopefully could either pay out 20 pence or not pay out 20 pence at the end of the day. The trading strategy that they carry on is really quite beautiful, as we'll see later on. Right, so in what follows, there's a lot of notation, but it's going to be pretty similar, so I'm just summarising it here. Little t is going to be the current time. S sub t is the underlying asset price at time t. K is the strike or exercise price, usually it's called the strike price. T is the option expiry date. Sigma is going to be the volatility of the underlying asset price. And then eventually we're going to assume that the asset is log-normally distributed or geometric Brownian motion equivalently. So it comes into the stochastic differential equation for ST. Little ct is the price at time t of a European vanilla call option on an underlying asset. Little pt is the price at time t of a European put option on an underlying asset. And capital CT is an American call option price at time t. Capital PT is the American put option price at time t. And R, which is going to be vital to, is our risk-free, continuously compounded rate of interest, which here we will assume is constant, but in more complicated scenarios you could make that stochastic as well, but we're not going to do that here. Okay, so factors affecting option prices. Right, you'll probably all have heard of Black-Scholes, which is the underlying model. It's a PDE approach. It's a PDE approach that won people the Nobel Prize, and essentially the Nobel Prize that they won, Black and Scholes, was for changing a greater than or equals to into an equal sign. That's what they got the Nobel Prize for. Because the equation, the terms, the combination of the equate terms that existed before, but as an inequality, and what they argued was it should be an equality, and that's what got them the Nobel Prize. Anyway, so these are related to the Black-Scholes model, all these assumptions that we're going to do here. But I want to run through some ideas as to how we might expect the call options or put option prices to vary as a function of these particular parameters. Eventually we'll do it properly, but this is just a qualitative approach. Okay, so if we consider a euro call, the payoff is this max of ST minus K at 0, which is that diagram up there. During the lifetime, as ST approaches that strike price, the likelihood of the change in the payout at expiry is going to increase. So if you're quite close to expiry and your share price is way down here, it's going to jump rather a long way to get some payout. But if it's very close to your strike price, it's only got to tip a little bit over, and then you might end up having to pay. Okay? So essentially, the larger the value of ST at a particular point, you kind of expect the greater the chance of a non-zero payout. So you'd expect the thing to go up, the cost of the option, because essentially that's the flip side of this. The cost of the potential loss to the writer, you would expect to go up. So you'd expect him to be compensated better, wisely than. Computer's shut down. Right. I was going to show you something, but I can't. Okay. So you can make a similar argument with the euro put, so that with a euro put, the lower the share price, the more likely you're going to have a payout, so therefore you expect the price to go up as the share price goes down. Okay, the strike price, okay, basically for a call option, the higher the strike price, if you had an infinite strike price in the limit, you would never get a payout. So generally, as the strike price goes up, you would expect the call value to go down, okay, because you're less likely to get a payout. Time to expiry, capital T minus T is the time from now, which is little t, to expiry, capital T. So essentially, the larger the value of T minus T is, the more opportunity the share price has to move in order to get it, if you're with a call option, to get above the strike price, or if you're with a put option, to fall below the put strike price. So under those circumstances, you expect long times to lead to generally higher prices. Okay? Volatility of the underlying share. Clearly, if you've got a share that is jumping around a lot, then it's more likely at some point to get over that strike price. Okay? And if it does that at the particular expiry time for a euro option, then you're going to get a payout. If you've got a very boring share that's not jumping around very much, then it's going to sort of hang around a certain price and it might not make the jump down here. So if you've got a low volatility, you expect that things will be cheaper. A higher volatility, you expect things to be more expensive. Interest rates, you will expect a higher value of a call option for high risk-free interest rates. Why? Because otherwise you might as well just put your money in the bank. Okay? If these things, why would you ever bother to invest in an option if you can get more money in the bank? Okay? So the higher the interest rate, the higher the value of the price of the option. There are some other things as well. Income received on underlying securities. If you've got a dividend income, so if your underlying security or asset is a share, it might pay an annual dividend or a semi-annual dividend or a quarterly dividend. So my wonderful Santander shares, I got a dividend from them the other day. Actually, what happens is they pay me extra shares, and then any money left over then is sent to me. Okay, so they give me a couple of extra shares as a dividend payment, and then they sent me the massive amount of £1.35. So I got £1.35 for these shares the other day, and of course I banked with HSBC. The HSBC bank has gone from up there, so now I have to drive into town to pay that check in. It costs me more to park my car in town than it does to pay the dividend in. So you ain't going to get paid dividend. So. Right. So that's if you receive a dividend on a share, okay, then clearly that will affect the value of the share as well. And you don't pass that dividend on to the value of the option holder. Why? Because the holder of the option is holding an option, they're not holding the share. It's only the share owner that gets the right to receive that dividend. So essentially, the higher the level of the income received, the lower the value of the call option, because by buying the option instead of buying the underlying share, the investor forgoes that income. There are models for including dividends in valuations of options. The most common one that we will look at later on is when you have a continuous drip feed of a dividend. So a dividend that's paid at every instant of time. If you have a discrete dividend, I think there's a bit in the back of the lecture notes which gives you an idea of how you go about paying a discrete dividend. Right, so now we get on to arbitrage. Right, arbitrage is basically getting a free lunch. Okay, so it means you do nothing and you end up basically getting something given to you for free. Okay, life normally isn't like that. Another way to describe arbitrage is, say, for example, Labour win the election in May. All the students, including my daughter, who are applying to university this year, okay, the Labour have said that the policy for reducing the tuition fees from 9,000 to 6,000 doesn't come in until 2016. So if you were in the position of my daughter, what would you do? Take a gap year, okay? So she's going to get the arbitrage scenario is, rather than paying £9,000 now, she just takes a gap year on mum and dad and then pays less fees in a year's time. That's an example of arbitrage, which Labour clearly have, maybe they've deliberately thought about it, but basically it's going to bankrupt universities next year if Labour win. So, because no students will come. Or we'll have to give them a £3,000 discount, in which case you'll complain because you'll want a £3,000 discount, and so there'll be a 30% cut in university funding next year. That's David Miliband for you. No, Ed Miliband for you. David wouldn't have done that, did he? And I speak as a Labour supporter. Right. Arbitrage. Right, so what is arbitrage? It's starting with nothing, but then getting something at the end of the day, okay? At some future time. So strictly speaking, it's actually not, you don't get it with certainty. The strict definition means there is a finite probability that you start with nothing, and then there's a finite probability you will end up with something positive, okay? That's the strict definition, but usually it's taken to mean, in the calculations that we do, it's that you will end up with a guaranteed risk-free profit, because clearly a guaranteed risk-free profit means you've definitely got a probability of 1 that you're going to get something. So it's consistent with that. So why is that important? Well, for a lot of arguments in economics and for a lot of non-mathematical arguments, you can get a long way in pricing things by invoking the principle of no arbitrage. So you assume that there is no way of making a guaranteed risk-free profit, okay? Or there's no finite probability you're going to get that guaranteed risk-free profit if you start with nothing, okay? In economics, it's also called things like the law of one price and stuff like that. But essentially, in maths, what it comes down to is a proof by contradiction. So it's a way of proving statements, mathematical statements about bounds on prices by trying to propose the opposite and then showing that that can't be true. So that's a proof by contradiction. So the general way of starting is you have to start with a hypothesis, a relationship, an inequality between various quantities, and you have to show that, pose the opposite, and then you have to prove it by that can't be the case. If you want to prove an equality, you have to show that both the greater than and the less than can't be true, and therefore the only other possibility is that the equals is true. Okay, so that's essentially how you do it mathematically. The general process of when you construct these arguments, and we'll go through several of them in a minute, the general process of doing it is, having posed the wrong answer, if you like, you sell the expensive side of the inequality, so the thing that's the bigger thing of the inequality you sell. You use the proceeds of that to buy the thing on the other side of the inequality, the cheaper side of the inequality. You invest the difference at a risk-free rate, because you'll have a positive profit from that. And at the end time of the period, in this case an option expiry period, you close your position off. So you might have to buy and sell some shares to get back to where you were. And then the idea is, if you've done the right thing in terms of the proof, you'll find that the wrong answer gave you a guaranteed profit, which therefore, by the assumption that there is no arbitrage in the real world, cannot be true. Therefore, the wrong thing must be wrong. Okay, that's the general argument. Now, the world, clearly there is arbitrage. All right. In fact, banks employ people called arbitrageurs, whose job it is to look for ways of making guaranteed risk-free profits. Okay. However, at least in pure economic theory, the assumption that there is no arbitrage is invoked. Right. So let's look at some bounds for option prices. Okay. So I'm not going to get you the exact answer now, but I'm going to go through and show you some lower bounds and some upper bounds so we can bound the price of these options at times before expiry. Why? Because generally that's when you buy the options. You're not going to buy the options at expiry. You're going to want to know what the price of the option is before expiry. Okay, so sometimes it starts off as a bit of a rabbit out of a hat, but if you know anything about pure mathematical proofs, you basically know what the answer is, and then you work backwards and rewrite the argument in the opposite direction. So I'm going to look for a lower bound. I think it's a lower bound. Yeah, on a euro vanilla call option. Okay. So how do I do that? Well, I consider a portfolio which is constructed from, and here's some jargon, I'm long one of the underlying assets on which I'm writing that option, and I'm short one of the call options. So what does that mean? It means long means I hold the underlying, and I write the call option. Okay, right means I go short, long means I hold. Okay. So why am I doing that? It's a rabbit out of a hat. Okay, well, just bear in mind with me and we'll see how it goes. Now, at time t, at expiry, what is the value of my portfolio? Well, the value of my portfolio at time t is I hold the asset, so I have assets worth S sub t, and I have written the call option. Now, as the writer of the call option, I'm in that scenario, so the writer of the call option has a liability equal to the amount that they would have to pay the holder. So that's my liability overall. So this is the effect of writing the option. This is the effect of holding the share. So what is this? Well, if we look at this, let's look at ST less than or equal to K first of all. So let's suppose that at expiry the share value is such that ST is less than K. If that's true, then what am I holding? I'm holding the share, and this liability, because ST is less than K, the option's expired worthless to the holder, they're not going to exercise, or the most they're going to come and ask me for is 0. Okay? So this is 0. Okay, so if ST is now greater than K, what's going to happen? Well, I've got ST, same again, but now the writer is going to come and ask me to settle up this amount, or we'll do the deal so that I've got to find the shares to do it. It's going to cost me ST minus K. So this is ST, and then this turns out to be K. So if ST is less than K, the value of my portfolio is at time t is ST. If ST is greater than K, the value of my portfolio at time t is K, the strike price. However, we can go further in that we can say that this is equal to ST minus CT. Okay, so that's the value of the option at that particular price at time. So what I can say that ST minus CT is going to equal ST if ST is less than or equal to K, or K if ST is greater than K. So the point is I'm trying to get a relationship for CT involved here. Okay? So this is where I actually put the value of CT in, and this is what I get. This is actually just saying this is what the value is. So this is pi t. Okay, so now here's the key step. That implies that ST minus CT is less than the strike price. Why? Look, if ST is less than K, ST is going to be less than or equal to K up there. So the payoff, even though it's ST, will be less than or equal to K. If ST is greater than K, the payoff is K. So in both cases, ST minus CT has got to be less than or equal to K. So overall, I can say that if I hold a portfolio which consists of one share and I've written one option, at expiry, the price of the share minus the call option has got to be less than or equal to the strike price. Okay? That's setting the scenario. Why? Because then the game that you play is as follows. Usually you start off with something at expiry, and then you can play a game to conjecture what the value is below expiry. And the way that it works is the following. So this leads to a conjecture. Okay, the conjecture is that that ST minus CT is less than or equal to K e to the minus R capital T minus T. So at T less than T, for T less than T, for all T less than or equal to T. Okay? Now where did that come from? That's definitely a rabbit out of a hat. Okay? Well, at a general time before expiry, which is what we're dealing at, S sub t is little s sub t, or s little t, okay? C capital T is C little t, okay? Less than or equal to, well, K is just a number, it's a sum. This thing varies in time, that thing is random, K is just a number that you pick at the start. It's the strike price, okay? It doesn't change. What does change is, as it's a constant number, it's like a sum of money, which if you put into the bank, will change according to continuous time interest rates. So what this is a discounted amount of money back from expiry to little t. So the way to read that is, K e to the minus RT minus T is the amount of money I would have had to have put in the bank at time little t to attract interest at the rate e to the r, okay, in order to have an amount capital K at expiry. Okay, this is the amount of money that I would put in the bank at time t. Okay, then that's at time t, and then at time capital T, the amount in the money would have risen to capital K. All right? So, in general, when you have a result at capital T, the earlier result will, if you've just got an ordinary strike price there, in all of these formula, it's going to be K e to the minus T minus T. That's a conjecture. I'm just making that up at the moment. I haven't proved that that's the case. All right? But I've got to start with a conjecture to start proving. So, how am I going to prove that? Right. Well, I'm going to prove by contradiction. So the assumption is, at the beginning of this, assume no arbitrage. Okay? I'm going to assume no arbitrage. And I'm going to start with no cash, or nothing. Okay, this was just a convenient way to get a conjecture. Now I'm stepping away and I'm going to assume that I'm starting with nothing. I start with nothing, and I'm going to suppose that the opposite is true. suppose that st minus ct is greater than or equal to k e to the minus rt minus t. Strictly greater than, right? I don't know. For some t less than t. So in other words, it's the opposite of that statement there. I assume the conjecture is that this is true for all t less than capital T, but I'm going to assume that there's some time at which the opposite is the case. Okay? Right, so what do? At little t, now remember the way that I argued. The way I argue is you sell the expensive, you buy the cheap. That's the bigger thing, that's the expensive thing, okay? That's the smaller thing, it's the cheaper thing. So the rule of thumb is you sell the expensive, buy the cheap. So what does that mean? It means that I've got to sell st minus ct. What does that mean? Well, it means that I short sell st because I start with nothing. So I don't own the share. The only way I can sell it is by short selling it. Okay? I short sell st and I've got to sell this one, so I have to short sell that one and I have to buy CT, okay? Because it's a minus sign in front of it. If I was selling CT, I would be selling CT, but with a minus sign in front of it, I'm basically buying it, okay? Right, so the point is that if I sell that, that costs me ST minus CT. Okay, I short sell, income. I short sell, I receive ST from the market, and then minus CT is what I have to pay to buy the share, buy the call option. Okay, so overall that's what I've got. And then I invest, then I buy, okay, I buy the cheaper thing, K e to the minus RT minus T. Okay, and basically what that means is I invest it. So CT might C. So and the point is that so blah blah blah. Hang on, invested in bank at R. Okay, and of course the key thing is this is greater than K e to the minus RT minus T by assumption. Okay, right. Okay, so let time roll on to expiry. Okay. I'm just going to try and finish it quickly. Right, so what happens is, well, the cash in the bank, what's the cash in the bank? It's ST minus CT times e to the R T minus T. Essentially, between time little t and time capital T, it grows to that amount by interest, constant risk-free interest. That, of course, is greater than K e to the minus RT minus T, which is that thing, okay, times e to the RT minus T, which is that thing, and it's all positive, so it's K. So we know that the money in the bank is greater than K. What is my liability? Well, my liability at expiry is, well, I short sold that share. I stole that share from someone at time little t. I better pay it back to them. So my liability is capital ST. Okay? I've also, because I bought the share, I bought the call option. That's actually not a liability because I hold it. So in terms of liabilities, I'm actually due a payment of CT. So if I wanted to close my position, I'd have to spend ST, but I would be receiving CT. okay, because I could exercise my option if I needed to. Now we know from here for sure, okay, from this one, that one is true. We know that's true. That's got to be less than or equal to k from 1, for sure. Okay, that's true. So what have we got in the scenario? Well, my cash in the bank is worth more than k. My liability is worth less than k. So if I actually work out what my cash in the bank minus the liability is, it's going to be something bigger than k. Well, let me just write it out all over again over here, sorry. So it's something bigger than k, and it's something less than k. So if I add up I subtract my assets minus liabilities, it's going to be something that's greater than 0. Okay? Now, what's happened? I started with absolutely nothing here. I assumed that this was the case. I carried out this trading strategy of selling the expensive, buying the cheap. That gave me some money in the bank, which I invested. Okay? That money I invested in the bank, over time, as I went to expiry, that money grew in value to something which was greater than or equal to k by this assumption here. My liability at expiry was, I'd short sold the share so I had to buy it back, but then I bought the option so I was going to get some money back from that point of view. This from here, we absolutely know is cast iron correct. Okay, we worked that out with expiry. So this is definitely correct. Take this away from that, my net position gives me something which is greater than 0. I've started with nothing, I end up with something. That is arbitrage. Because I turn nothing into something greater than 0. Right? I've got arbitrage. So, what has gone wrong here? Well, the assumption was that there was no arbitrage. If we assume that there is no arbitrage in the world, something must have gone wrong. This statement is definitely true. Okay? That we did work out. So the only other thing that can be wrong is this statement. That statement was our starting assumption, which was wrong, so we can't have. So if no arbitrage, we cannot have ST minus CT greater than or equal to K e to the minus RT minus T. That cannot happen. Okay, that's wrong. So the only other way that that can happen is if ST minus CT is less than K. I mean, triple stick is greater than, so it's less than. All right? So we've proved by contradiction. This has to be wrong, can't be true. So the only other thing that can happen is the opposite, which is that one. Okay? That's arbitrage. So basically it gives us a bound on the share price and the option price. And actually if you redo that, you can see that it's CT must be greater than or equal to ST minus K e to the minus RT minus T. Okay? When you rearrange this, hit this one here, then you find that a lower bound for the option price at time t is the share price minus the discounted from expiry strike price. Okay? Right. Having scared you witless there, we shall pick that up tomorrow. Okay?